Good morning, students. In this video, we are going to see about a problem of Newton-Raphson method based load flow study. So, kindly watch the video.
This class we work out on problem using Newton-Raphson method. This is a two-bus system. Bus 1 is a slack bus, voltage is 1 angle 0. Bus 2 is a load bus, the load is 150 megawatts plus J50 megavolt ampere reactive. Base MVA is equal to 100. Line series impedance is 0.12 plus J0.16 per unit. The question is, calculate V2 and delta 2. Using Newton-Raphson method, perform one iteration only. First step, we have to form a Y-bus matrix. This is a Y-bus matrix of the system. 3 minus J4, which is in a rectangular form. In polar form, 5 angle minus 53.13. This is 5 angle 126.87. This is 5 angle 126.87. This is 5 angle minus 53.13 degrees. Next, I assume delta 2 is equal to 0. V2 is equal to 1. Second step, I have to calculate P2 and Q2. We know the formula. Here J is a running variable. I is a fixed variable. I is equal to 2. J is equal to 1, 2. Now, I expand the equation, I substitute all the values, calculated P2 value is 0. Similarly, we know the general formula of Qi, here I is equal to 2, J is equal to 1, 2, expand the equation, substitute all the values, calculated Q2 value is 0. Step 3, I have to calculate the specified value of P2 and the specified value of Q2. P2 specified is equal to Pg2 minus Pd2. Since it is a load bus, the generation is 0. Therefore, 0 minus 150 by 100. This is base MVA. That is equal to minus 1.5 per unit. Similarly, Q2 specified is equal to Q2 generation minus Q2 demand. 0 minus 50 by 100 minus 0.5 per unit. I can calculate del P2. That is P2 specified minus P2 calculated. P2 specified is minus 1.5. This is P2 calculated is 0. Therefore, del P2 is equal to minus 1.5 per unit. Similarly, del Q2 is equal to Q2 specified minus 0.5. Q2 calculated is 0. Del Q2 is equal to minus 0.5 per unit. Fourth step, I have to find the elements of Jacobian matrix. I did a mistake. Qi is equal to minus. This is minus sign. Therefore, Qi is equal to this is minus sign. This is minus sign. Not a plus sign. The answer Q2 calculated is 0. Next, we have to calculate dou P2 by dou del 2. Dou P2 by dou del 2 is equal to 4. Dou P2 by dou modulus of V2, that is equal to 3. Dou Q2 by dou del 2, that is equal to minus 3. Dou Q2 by dou modulus of V2, that is equal to 4. So this is the Jacobian matrix. Step 5, I rewrite the matrix like this. Next, I have to find the inverse of this matrix. This is the inverse of this matrix. Now I can easily calculate del 2 and del modulus of V2. So the delta 2 value is minus 0.18 radians. The change in modulus of V2 value is minus 0.26. The new value is, the old value is 0 and 1. Now delta 2 new is equal to delta 2 old. Old is 0. The calculated value is minus 0.18. This is in radians. Into 180 by pi, that is equal to minus 10.31 degrees. That is delta 2 nu. Similarly, Del modulus of V2 nu is equal to old value is 1. Del modulus of V2, the calculated value is minus 0.26. This value is 0.74 per unit. Therefore, V1 is equal to 1 angle 0, V2 is equal to 0.74 angle minus 10.31 degrees. The first iteration of the Newton-Raphson method. In the second iteration, we have to use this value and proceed up to the convergence. This way we have to work out this problem. Thanks for listening.
So, in this video, we saw an important problem in Newton-Raphson method. So, with this unit 2 ends, in unit 3, we will be seeing about symmetrical fault analysis. Thank you.